Hello everybody. Once again I am here with you for the another part of this transport phenomena of gases. Self-diffusion, transport of mass. Basically, we have seen in the previous sessions how the transportation of momentum rises the viscosity, and also the transportation of thermal energy causes the thermal conductivity or the rise in the thermal conductivity. That is what the transport phenomena. Now here the transport of mass, that is concentration of the number of molecules, how it affects the diffusion, that we will see. So same phenomena, the maximum number of diffusion is due to the transport of mass, this diffusion. A region of a higher concentration to a region of a lower concentration, that is transportation of the gas molecules. Now this will cause to the equilibrium position transportation, and here the same OX along the uh, layer, ground layer. CD is the upper one, AB is the little bit upper one, and the EF is the most upper one. Now this AB is suppose having the number of molecules because it is related with the concentration part, and that's why N be the we will have to focus on the number of molecules inside that layer and in that layer. Now here AB layer containing suppose n number of molecules, and no doubt the upper layer EF will contain the n plus lambda dn by dz, and the lower CD layer will contain the number of molecules, that is n minus lambda dn by dz, where dn by dz is nothing but the concentration gradient. As velocity related variation with the distance, that is velocity gradient. As the thermal temperature gradient related with the temperature versus distance, here the concentration versus the distance. As the distance increases, the concentration according to that is going to be increasing about the number of molecules. And here is the three layers. No doubt 1/6 of the gas molecule will transfer from EF layer to the downward, and 1/6 of the gas molecules from the lower concentration will move towards the upper layer. So this is what the process of the transportation of the concentration or the mass of the transportation of the gas molecule, and which will cause to the diffusion rise, or the equilibrium position will be generated with that case. So here is the concentrations of the different layers as we discussed. Now the number of molecules coming from the uh, layer EF and crossing AB downward per unit area per second, as 1/6 of the gas molecules are going to be transferred, and that is somehow it is given with 1 by 6 C n plus lambda dn by dz, because all it is about the concentration moment only, therefore the C is going to be the part average molecular velocity of the molecule, and 1/6 of the molecule of the whatever the concentration is going to be downward. Similar way, the 1/6 of the gas molecule from the CD layer will cross per unit area per second, and it will transfer nearly 1 by 6 C into n minus lambda dn by dz is the case. This much amount of the concentration of the molecules will transfer from the CD layer to the upper layer. Now if in this case, sorry, so in this case suppose the net number of molecules crossing per unit area per second of the layer downward direction, if I want to find out, because maximum concentrations are going to be downward, lower concentration molecules are coming upward. Now the question will be rise how it is to be there. As this suppose the upper layer is containing the 600 molecules, and 1/6 of it that will become to be 100. That means 100 molecules per second will go downward. If suppose downward having the only 60 molecules, because lower, that's why number of molecules are less, and 1/6 of this will be definitely 10. That means 100 molecules coming downward, 10 molecules are going upward. So that's why whatever be the 100 versus the 10, that ratio, that means difference is there as far as concentration of number of molecules are going to be transferred. And that's why the net amount of the molecules crossing per unit area uh, per second is nothing but to be given with 1 by 6c uh, into n plus lambda dn by dz minus 1 by 6c n minus lambda dn by dz. And if 1 by 6c is to be common, 1 by 6c lambda dn by dz. Now here this is to be common part as an n, if suppose n minus n, that will be n will get cancelled, and this lambda dn by dz minus minus, this is plus lambda dn by dz, so it will become 2 lambda dn by dz, so be click saha, that's why again it will become 1 by 3 c into lambda dn by dz amount of the net amount of the molecules crossing the layer area. So as far as constant coefficient of diffusion is concerned, it is the ratio of the number of molecules crossing per unit area in a 1 second to the rate of change of concentration with the distance. And it is given with the dn by dz, that the rate of change of concentration with the distance, that is d into dn by dz. So coefficient of diffusion d is equal to, it is nothing but to be 1 by 3 uh, c lambda dn by dz divided by, again this will be equal to the our quantity 1 by 3 c lambda dn by dz, and that's why dn by dz जर इकडे राईट साईडला गेला तर इट विल बी भागिले उलट गुणिले हे कटून जाईल, आणि रिमेनिंग अमाउंट d will be, diffusion will be 1 by 3 c lambda. So this is what the diffusion change will occur as the concentration of the molecules are going to be transferring from one layer to another layer. And net change in the whatever be the in the diffusion will be relationship given with 1 by 3 c lambda. Now the effect of the temperature on the pressure and the pressure on the diffusion is simply given with as in this case lambda is always to be written in this fashion, kt upon under root of 2 pi sigma square p is there. So again c is nothing but to be given with value, that is the c is equal to under root of 8 kt by pi m. And in this case, if suppose I want to write it for the d is nothing but to be, I can write 1 by 3 so in this case d is equal to 1 by 3 kt under root of 2 pi sigma square p, again into lambda value is to be written as under root of 8 kt by pi m. So again if I simplify this relationship, so this 4 into 2, that means 2 will come out, 2 will be remaining as it is, and under root 2 and under root 2 will get cancelled, and the 2 will be remaining out, therefore 2 by 3 1 by sigma square p under root m into kt by pi raised to 3 by 2. So this is what the output for that particular case where we are putting the values, that clearly indicating it is the coefficient of diffusion is directly proportional to the under t raised to 3 by 2, and inversely proportional to the pressure, because it is under divided by, so it is inversely proportional to the pressure and directly proportional to the t raised to 3 by 2. म्हणजेच डिफ्युजन हे जे काय आहे डायरेक्ट प्रोपोर्शनल टू आहे अंडर t to the power 3 by 2 and inversely proportional to the pressure. So as far as relationship interconnecting relationship in between the eta and the d is concerned, eta is always to be written as previously 1 by 3 rho c lambda, and the d we calculated 1 by 3 c lambda. So in this case जर समजा d ला मी रो ने मल्टिप्लाय केलं दोन्ही साईडने, तर ही राईट हँड साईड मॅच होते. सो इटा इज इक्वल टू डायरेक्टली मला म्हणता येते रो डी, आणि त्याच्यावरून डी जर लिहायचं म्हणलं तर हा रो इकडं जाईल, इटा बाय रो विल बी देअर. सो दिस इज व्हॉट द रिलेशनशिप इन बिटवीन दी eta and the d diffusion, that is the viscosity and the diffusion part is there. Again, this can be written in this fashion also: d is equal to f dash eta by rho, that is the numerical factor whose value is 1.4 f dash. That is also the part it for the more perfect values for the d. So this is all about the diffusion, and I thank you for joining this session. In this case, this third unit is also going to be over. So be at home and be safe. Thank you.